Hello, welcome back. We are going to start the first challenge of the Ethernaut series. And first things first, I struggled like crazy. The learning curve here is very steep. So if you are feeling anywhere incompetent of not being able to achieve this, I promise you, if I can do it, you can do it. So first things first, I need to give credit where credit is due. And that's going to be to this YouTuber here. So his name is Web3 Blockchain Developer. So he's created this series on Ethernaut, specifically how to solve each challenge. It's slightly outdated, so it's dated 2020. So some of the stuff, so he uses a different test net than I do, and there's a few minor differences, but it was definitely useful to watch him try to figure this out. Reason being is I spent probably, I'd say, an hour or so tinkering with the console, reading about certain things, trying to figure out how to solve it myself, reviewing the code, and I struggled. So having his assistance was very useful, and hopefully my assistance here from a different perspective, breaking down some of the areas that most would assume others would know, and I didn't, so I had to dig a bit deeper into certain terminology and what certain things meant, and how to interact with the blockchain before actually being able to exploit this code. So with that being said, let's get this party started. All right. So here you can see there's a few different things. So this challenge is called Fallback. So that's your first hint. And if we look at this, it states how to win this challenge, how to beat this level, is specifically two things. First, you have to claim ownership of the contract. Then you need to basically withdraw all the balance to zero. And if we can accomplish these two things, then we win. And you can see the difficulty is 1 out of 10. I just noticed this. I didn't even know that. That makes me feel so much better about myself. All right, and things to help you with this whole process, things that might help. First here is basically how to send Ether, interacting with the ABI, how to send Ether outside of the ABI, converting to and from way in Ether units, and fallback methods. This is one thing that was useful to kind of guide the areas that I needed to research and learn more about when getting an idea of what knowledge and practical skills I needed to actually exploit this specific challenge. With that being said, I'm going to show some of my notes here. So you can see I have a series of notes here that I want to walk you through and a bunch of links that I felt that were useful. But first things first is we want to review the code. Because this challenge, and I'm assuming a lot of the future challenges, they're going to give you the source code because that's kind of what auditors do, is they look at the source code and they do a series of other things. But we're going to take a look at the source code, we're going to walk through it together. And I have it here, just for me it's easier. Okie dokie, starting at the top. And if you think the first video was long, this one I feel like it's going to be real long. All right, so first things first here is we have our compiler in this specific version of compiling. Remember last time in the first video I mentioned that having a floating point like this is actually a bad practice. It's preferable that this is gone and you just have the straight up number. So when you deploy your contract to production or the main net, it should be 0.6.0 with no floating point behind it saying that anything above 6.0 is okay. So that's the first thing I'll mention here. Next thing here is you can see this contract's importing safe math. So this import statement is basically stating that from OpenZeppelin, I want to import safe math, which is going to allow me to figure out different ways to utilize math in a safe manner. I'm looking at, there's a cat over here. It's freaking out. Chill out, cat. I'm trying to make a video for the internets. Cats, so entertaining. All right, so we're importing safe math, and you can see that down here, after you've imported safe math, you're gonna have to run this specific section here, which basically says that I want to using safe math for UN256. And that doesn't really play into much of a factor here, but just understanding that when you're looking at a contract, there's most likely going to be a series of import statements, either importing security functions and security contracts to help build the robustness of their contract, or you're going to be importing contracts and functions and things like that from other contracts so you can build on top of each other. This really goes back to the composability standpoint of blockchain and how that's kind of one of the underlying pinning methods of why people enjoy this. All right, here we have our contract, stated fallback. We have a few different state variables, so we've already mentioned this one with the safe math. Another state variable we have is actually a mapping. So this mapping is basically saying that the address connected to this integer is going to be the amount of contributions. So this the amount of contributions tacked to a certain address or certain EOA, externally owned account. And then here we have another state variable, which is going to be an address, and it's going to be payable public to the owner. So basically, this is the address that can receive funds. All right, and next thing is we have a constructor. So constructor, like at the beginning of their contract, this is, unless it's an upgradable contract that has an initializer, but most of the time you'll see things that aren't upgradable with a constructor, which basically means that as soon as this contract initializes and it kicks off and it's deployed to the mainnet, this should only occur once. Shouldn't occur multiple times. So once it kicks off, this happens. And once this kicks off and this happens, there's a few things that are going to occur. So first, the sender that interacted with this contract is going to become the owner. Another thing is here is the sender here, they're basically saying that we're going to take 1,000 and times it by 1 ether, and that's going to be the amount of contributions that that specific sender has initialized when interacting with this contract. Another thing is here is modifiers. So you'll see modifiers quite a bit when interacting with contracts, specifically those that utilize Open Zeppelin smart contracts. And a modifier is something we've discussed in previous videos, I think with Securium in the Solidity section of the bootcamp. But specifically, we can kind of review this quickly. So a modifier is something that you can lay on top of functions to modify their functionality in a specific way or specific manner. And specifically, this modifier is an only owner modifier, and it's you can see it as a way to control access. It's an access control for security purposes. And with the access control of this only owner, what we're going to do here is we're going to ensure that the only person that can interact with a specific function has to be the owner, and that owner's they're gonna match that with the sender. If it's not that, then they're going to basically fail, and it's going to say caller's not owner. And then if it is true, then it'll continue. And that's specifically what this underscore and colon stands for. So if this equals true, then run to this, and that means basically continue the function. And we'll jump down to the owner piece just to show you what that looks like. So here you can see at this function down here for the withdrawal, we have specifically the only owner modifier laid on top of that function. And you can see that this is a public function, and it's basically going to allow you to withdraw, but you have to be the owner to do so. And it's basically calling out the transfer the address and transfer the balance from this contract to that owner. Next, we have two other functions we'll cover here. So this one is contribute, and this one's get contributions. So simply, this is going to be a public payable because we're actually sending funds to it. So we want to contribute a certain amount of ether to this this contract. So first things, we're going to do a check. So we're going to basically ensure that the value is greater than this set of ether. Then we're going to actually do a quote-unquote effect. So we're going to actually take the sender, we're going to add that value from that sender. And then here we're going to do a conditional. So here we want to ensure that the sender has sent more than the owner. If so, then we'll make the sender the owner. And that's basically that function. This one's getting the contribution, so it's a public view returns, so that there's no writing occurring here. So this one's free. You can do it as much as you want without taking any additional cost for your ether. So this is public view returns, and it's going to return uint, and it's going to basically check out the sender and the contributions, and it's going to send that back to the uint there. Now, the last one here is an interesting one, and you'll see when we solve this challenge, this specific function really plays a key role in us actually, exploiting this. So here you can see that this specific function actually doesn't have the term function for it. It just says receive, and we'll discuss that later on. But what you really need to understand is that this specific function is a fallback function. This cat will not leave me alone. He's like, hey, you're making a video? Not today. All right, I'm going to put you down. Back to what I was saying. So this receive fallback function basically is stating that anytime that ether is sent to this contract and there's no specific function that's specified, then that money is then transferred straight into this function here. And when it does that, because you can see it's external payable, when it does that, you want to ensure that the value is greater than 0 and the sender's contributions is greater than 0. If so, then we're going to allow that sender to be the owner. So I'm going to dive more into specifically this section. We'll do that later on. So now we reviewed this contract and we have a general idea of what's happening. right? So we have a series of state variables that are being established. We have a constructor that kicks off and ensures that whoever interacts with this is the owner. We have a modifier that ensures that the withdrawal function, the one that is part of the second part of the challenge of how we succeed, is only the owner can do this. Then we have two other ones that are basically allowing us to put money in and also us to check the amount of money that we've put in or somebody else has put in. And then we have the last one that's kind of somewhat of a fallback or a hidden function that takes the ether that's sent to the contract if no other function is specified. Cool. So we've reviewed the code. We've got that out of the way. So, I'm going to start marking this stuff off to make myself feel better. Oh, cat left. We're winning. All right. So one of the areas that caught me off guard actually when interacting with this, and let's kind of kick it off, right? So I think we're connected. That's cool. So I'm going to show the terminal and we're going to interact with this contract. So if we do an await contract, and before I do that, let's take a step back and say, like, how do you even know to do that? That's one thing that I consider to myself is if we do the help, because the reason I'm doing help is you can see specifically here it says you can use help to help you understand what you need to do and what you can't do. Knowing that we can do contract is something we learned in the level 0. So if this is confusing, you can check that out. But we have our own specific instance right now of this overarching contract for the challenge, and we can interact with that contract by just typing contract or await contract. Await contract is just going to make it a little prettier for us, so we don't have to go through all the promises and things like that. So if we open this up, and if you remember from level 0, the ABI is a key factor here because the ABI is allowing us to see that this deployed contract, what specific areas of this contract can we tinker with and we can poke. Then we can either put stuff in or take stuff out. That's kind of the ABI. And with this ABI, we can see there's a few items mentioned here. So we've reviewed all this stuff in the source code already, so we don't have to regurgitate it, but quickly you can see that there's a constructor that we've talked about, and we have a series of functions that we've talked about. And then we have this specific one down here is that receive function that doesn't have a function type specifically. So those are the areas that we can interact with. And if we look at all of these, we can start interacting with them and kind of seeing what's inside. So say we want to do await, and we'll do a contract, and let's do owner. Let's do owner. So if we do owner, we'll get a response back here that says that's the owner. And to remember, this is our address, right? So we're the player, and this is the owner of the contract. So one of the big things that we want to do is we want to actually become the owner so that we can withdraw all the funds. So one thing that I learned from the other YouTuber that taught me this whole process is actually when sending money to a specific address, I didn't realize that when doing this, what you're sending is actually inside of a JSON object. So what I specifically mean by that is when you want to send funds to this contract, you have to call a specific function that's baked into, it's kind of like a global variable within the Ethereum ecosystem. And there's a series of these. So if we take a step back, I have a series of links here. So one's for MetaMask. It's basically explaining what send transaction does and is. And the reason this is useful for me is actually if you look here inside of this this bit of snippet of code, it kind of shows you at this top here what's occurring and how it's actually sitting within an object. Because to interact with the ABI that you're interacting with on the Ethereum network for that smart contract, instead of just sending a straight up value, which is what I was doing and I was getting an error, and I'll actually show you the mistake I was making. So I was basically saying I want to contribute. I want to contribute funds. So I want to say like I want to contribute 4 ETH. So maybe I would do this. No, that. No, stop correcting me. I'd do that and I'd still get an error. And these errors specifically are stating that you're incorrectly contributing money. You're not contributing it in the right manner, and it's not taking in what it should take in. And it took me a long time. I would say a little while to realize that these global state variables that are within the ecosystem of sending a transaction for this here, and how these are constructed, because there's a series of data elements that fit within inside of this object that you send to that contract. One of which is a nonce, gas price, etc. what we care about is the value, because we're sending a set amount of value to the contract. And to do this, we would do like I showed you previously, where we're actually going to put this in here, and we're going to put it inside of a JSON object, which is the curly braces. We're going to then state that it's a value, and the reason we know that that is called value is based off of our research here, that we found out that the ETH transaction method that's baked into the ecosystem takes that value here. And then we're going to just do one for now. I'll say send, and then what's going to do is it's going to contact our our setup here and say, hey, do you want to do that? We're going to say yes. And then once we've done that, it's going to run through here, and you can see that the value we've sent is one way because it's the smallest metric for Ethereum. And once it's done processing, it'll error out, tell us that we're wrong. Figured it out. Fail and keep failing. Just do it over and over. It's great. It feels so good. All right, the reason that this is failing, and I'm sure if we would have thoroughly read the errors, we would have realized this, is down here specifically, we're trying to send a transaction to the contract without contributing, and by doing that, we're actually not following one of the instructions here. Oops. Here you can see that basically it states that the contributions from the sender has to exceed 0. If not, then this is going to fail. And we're actually trying to skip that part, but we actually need to contribute first before we can send a transaction. So, start this again. So we want to contribute, which is one of the methods we have. And I was right with the JSON object. That still matters. And we're going to do a value of 4. Now, this should work correctly, because we're going to contribute. And once we've contributed, then we're actually going to be a part of the contributors. So we have a series of steps that need to be taken here, and the mapping that we've discussed about up here for this mapping here, we were not part of this list. So there's a mapping and there's a bunch of key value pairs, right? So we have an address and then the amount contributed. Here we had the owner, and then we had how much ever they put in there. But below that there was nothing. But as soon as we contributed with the function we did, so we did a contribution, that added us to this mapping. So this is me and my contribution of 4. So now I'm part of this mapping that's being discussed here in the state variable, which also means that if I'm a part of this, down all the way down here, so we're going to have to scroll down to see it, this conditional here that's saying it's a require statement of saying that if you want to send a transaction to this contract, you first have to meet this requirement, meaning the sender here has to have more than 0 and be a part of the mapping above that we just discussed. So now that we've done this, it's not errored out. It makes me feel good. And also if we go here to the testnet, we can see that this has succeeded and we're a part of it. So now that we've contributed, we can actually see if our contributions are visible. So if we do contributions and we do player, if we open up this this promise response, we go to the words here, we can see the length is 4. So previously this was 0 because we had no contribution. So we're now a part of that list. So this is a big milestone for us. We're making progress here, folks. I hope you feel good about it. All right. Now, I skipped over some of the objects conversation there because I wanted to really spend most of my time discussing Web3.js. First things first, before I dive into my explanation, I highly recommend you just go to this guy's video series, and it's DAP University. He explains Web3.js very well and does it through actually building things and interacting with it instead of just talking about theory, but actually practicing with it. So that helped me a lot understand what Web3.js is. But in addition to that web series, or that video series, there's a series of links I have as well that were useful for me to understand it. So I've linked a few here. But the way that I thought through it is I had to break it down very methodically to understand specifically what Web3.js was doing and the important parts of certain components of Web3.js. So if we scroll down here to look at a high-level view of what's happening, I'll make this, this photo a little larger. Maybe not. Okay, I lied. I'm not going to make it bigger. But what I will show you and point out is there's a few pieces here. So this little circle here is Web3. You can see is like Web3.js, right? And then specifically, the way that we're going to interact with the blockchain is through Web3.js. And that's going to use a specific thing which is named a JSON RPC. And we're using JavaScript. And as the Web3.js interacts with the overall blockchain ecosystem, it's going to then work through an EVM client onto either a local blockchain or onto the whole mainnet. And that's going to be our, I guess, our gateway or our door into the Ethereum ecosystem, and also our ability to interact with contracts and different bits of data on the blockchain. And that was a really important thing that I needed to kind of learn throughout this process to understand how to interact with the blockchain in the correct way. And if we go up here, specifically I mentioned JSON RPC. So JSON RPC is a way for us to make specific calls in a JSON format to the blockchain so we can actually get responses back. And I had to do a lot of reading and understanding what this meant. So if we dig into a few of these links that I've saved, nothing groundbreaking, but I read this one first, which is a blog post by this group here. I think they're, I'm not really sure what they do. But anyways, they talk some about the remote procedure calls and what that means for JSON RPC. There's some advertisements in here and stuff like that, so that's not always fun. But you can always go to Wikipedia. And if we break this down, I'm actually going to jump back to another term here is RPC. So JSON RPC is obviously a combination of two terms, right? So we have JSON and RPC. So JSON, as I'm sure many of you hopefully know, is a specific data format. It's a data structure. So we've been interacting with JSON or JSON objects within the Ethernaut bootcamp here, or the Ethernaut CTF, where we had those object structured items with the curly braces. So if we go back here and we look specifically, we'll give an example of our ABI. So this section here, these are a series of objects, right? You can see it says object here and it has the curly braces. That is a JSON format, right? And that is the first part of this RPC piece. And then the second part of RPC is a remote procedural call. So reading into this and understanding what it is, I found a diagram that kind of helps explain it, but the remote procedure call is something that a lot of you probably know, which is a call out to a server. It's the client-server relationship. So here we have a specific diagram that kind of walks you through a high level what's happening. So we have the client, which is your computer, and the server, which is usually some server and a data farm. And we have a call. So this is the remote procedure call. So it's a call that's done remotely to enact a procedure. Just got to turn the word around and you understand it. So we have our call procedure, which is a request message. That's going to be sent out here. They're going to receive the request. They're going to do some sort of procedure. So that's the remote aspect of this is this remote here. So we have our remote, our procedure, and then in addition to that, there's a call that's occurring, right? So that's the call piece here. So if we kind of put that together, we have a remote procedure call. So our client is calling remotely to this server to do a procedure. Then that's going to send a reply back to tell us exactly what's happening and how it functions, or what it's done for us to help us out. So that's one really important piece that I needed to grasp before I could actually understand what I was doing when I was interacting with the blockchain, or at least with Ethereum through Web3.js. And this is a useful article here. This walks you through some of what's being discussed here as well, so that's useful. And that is that. Now, that helped me understand kind of how I was interacting with it. Web3.js, and I think I have a link here maybe? All right. So I'm going to open up a few links for you so I can explain this a bit further that I found useful. So the JSON RPC is something we discussed with Wikipedia. That's a common thing that's used elsewhere, but there's a specific series of documentation from the Ethereum community that talks specifically about how they're leveraging JSON RPC and what that means within the context of Ethereum. But in addition to that, you can see it's linked down here that Web3.js is somewhat of an implementation or an abstracted layer over top of the JSON RPC of how you can interact with the blockchain specifically for Ethereum. And they make it easier through a series of wrapped functions and methods that you can use on your in your console or inside of your dApp to interact with different contracts back and forth, or at least from the front end for the user. And if I open up a few more of these, I'll actually go to the documentation for Web3.js. So this was useful as well. So just reading through kind of the introductory, reading through getting started, things like that. But most of all, that web series was useful, or that video series. So I recommend checking that out. So now that we have a general idea of what Web3.js is and how it fits within the overall picture of how us interacting with these series of functions that have been created by Web3.js, which we can go to their documentation here, and we can go to getting started, and we can see that there's a series of functions that we can interact with. So you can see that it's talking about send transaction, and there's specifications here. So there's different types of things you can send, events that are emitted. Down here you can see there's a series of extensions. So there's subscribe, contract, accounts, personal, ABI, things like that. And these are different kind of methods within the Web3.js library that you can leverage for yourself to interact with the contracts on the blockchain. Now that we know this, the very next step is actually gaining access or gaining control or ownership of this contract. And remember, if we kind of go back in time, when we were reviewing this contract and kind of going everything here, we saw that there was a few conditions that had to be met down here for this specific function for us to interact with it. We want pink, not black. All right, so this specific condition has been met, so we're good there. Reason being is we've contributed. Now we're part of that mapping that we discussed above. Now the next thing here is we want to ensure that the value that we've sent to this via a transaction is greater than 0, meaning we want to send a transaction to the contract. Now, how we discussed is there's two ways that you can send a transaction to this contract. One is by specifically and explicitly notifying the contract that we want to interact with the contribute function, but that's specifically stating that. Or you can send this transaction straight up without mentioning any specific function, and that's then going to default to this receive function. Now I didn't know that until I did a lot of reading to understand what that meant. And there's a series of links I put down here that help explain that specific concept. So this first one is talking about how to actually send a transaction and what that actually means within the context of the JSON objects and Web3.js. And they specifically walk you through that sending a transaction or sending it inside of an object. So that's the curly braces for the JSON piece I've talked about. And inside of there is all the data elements that we've already discussed historically. That was within the MetaMask blog that kind of showed you what that looked like. And this is just another explanation of that for the send transaction, but this is in the context of the JSON RPC API. So this is a little bit, it's the same thing, same concept, but just not necessarily associated directly with Web3.js. Web3.js has their library that you can use web3.eth and then that extension. Or if you're using directly the JSON RPC, you can potentially just utilize this and just do eth_send transaction. So that's the one piece of understanding, like to do this, we need to actually call this specific method so we can send a transaction to the contract. Another thing that's really important about all this stuff is understanding what the receive function specifically does within a contract, within a Solidity contract. And that's very valuable to us because if we understand specifically what this function does and how it responds to a transaction that's sent, that allows us to understand, to know that if we send a transaction to the contract and there's no other fallback function discussed, our sent transaction is going to automatically kick this off, and it's going to allow us to then become the owner. And we know that because we've took the time to read and understand from not this or that, from this specific section here that walks you through what the receive function does and how it interacts with transactions that are sent. And the alternative here is that if you do have a fallback function here, so you can either have a receive function or a fallback function. You might be able to have both, just in case the receive function defaults or something happens there that's incorrect. It'll default to the fallback function, so you can have two of those maybe in once. So now we have a general idea of what the receives function's purpose is and what a fallback function's purpose is and how to send a transaction to a contract. And with that basic understanding, now we can actually jump back into the console and we can hopefully execute this correctly and it'll work for us. So if we do a wait contract and we want to do a send transaction, we know that this specific method here exists, and the reason we know that it exists is because of the reading and the research we did previously with Web3.js and also the JSON RPC. We know that this send transaction is a global variable that sits within the overall Ethereum ecosystem that we can interact with. And we know that the key is going to be value because of the research we did. And we know that we can send really whatever. And if we do this, we should, in theory, not get an error. And as that loads, I'm gonna mark stuff off because it makes me feel like I'm making progress. And I know you care about that, internet. All right, so we did that. We talked about this. And the last thing I'll explain or share is this is another Stack Exchange post that talks about the receive function and specifically what it does and why it exists. So I thought this answer was a good one. I wanted to share it with you, so I'll include it in the links in the YouTube channel. All right, so it didn't fail, which is a success. We've done something good here. All right, so we sent the transaction. We can check here, and I think it should be completed, right? Why is it loading? Oh, maybe it's the block is still being confirmed. All right, well, the transaction sent. So now, hopefully, if we do owner, we can see that we are the owner. So, congratulations. We've done the first part of this challenge. So the next part is going to be pretty straightforward. So if we look back at the contract, if you remember in the ABI, there was another method we could call here, or another function, that was called withdrawal. So withdrawal here is going to allow us to withdraw the funds, and we know that because we looked at the source code, and we saw that the modifier here that states that you have to be the owner to this, which we've passed, so this modifier is going to continue, and we can check that off. And then down here, if we're the owner, that means we can transfer the funds out of here. All right, so if we do await contract and withdraw, confirm that, that should work. And we'll go back here and I'll quickly reiterate the modifier piece, because when originally researching modifiers, I was quite confused by specifically what this little underscore and semicolon meant. So if we have our function here, right, and we have say this is like the title of the function, and then we have some code in here, right, and then we end the function. So our modifier is up here, and we have our modifier here, and we have some code in here. So say this code here is going to be our underscore and our semicolon, right? So we're basically saying that this requirement has to happen. If this requirement is good, then I want you to continue to this piece here, which is actually stating that if this is true and this meets what it needs to be met, and we can go to the underscore semicolon, that's basically saying I want you to then kick off this function and continue the execution here. If not, then I want you to fail and don't allow anything to happen. So the underscore semicolon is basically saying continue the function, continue the execution. And that's allowing us to withdraw. So with that explanation, come back here, no failures, which is good. I'm hoping that if we do, I think it's contract contributions. No. So we have our contributions. I'm assuming that we've won. We've done it. I'm trying to figure out how do we know? All right. So after researching some stuff and cheating, I figured out how to show where there's no balance. So we've just withdrawn the balance, and I wanted to confirm that we've actually done that. So we'll start from scratch. We've withdrawn it from the contract, and to show that that's happened is there is a global method, as per usual. That's basically something you can get from the Web3.js documentation. And what we want to do is we just basically want to say the contract that we're looking at and the address specifically for that contract. And by doing so, we can see that the value is 0, which wasn't the case previously before we drew the funds. So with that being said, we've done everything hopefully correctly, so we can submit our instance and move on to the next phase. And as this mines, I'm going to go mark off my notes. And voila, we've completed the level. Here you can see that it says, congratulations, level completed. You've learned the basics of all this junk. Go to the next level. Internet, I'll see you on Fallout.